Hi, one of our local farmers asked would I be to have a look at this Milwaukee Rapid Charger. Now I have had a look at a couple of these before and there've been a couple of different faults on them. I think one there was a little resistor had gone and one a diode had gone. So I don't know whether this is going to be the same or not. So let's plug it in. We'll plug it into the dim bulb tester in case it decides to blow up on the bench. And all that is a bulb wired in series with the socket there. So if there's a short on this, all it'll do will make the bulb light up and hopefully save the electronics instead of it going bang. So let's plug it in and switch it on. And the bulb didn't do anything at all. So to me this isn't drawing any power at all. So I would think something like a blown fuse or something. Right, I'll get this out of the way. And we've got 5 T10 screws, I think it is, on the bottom. So I'll just grab a screwdriver. Right, that should be all of the screws out. I think you're going to pop this little thing in if I remember right. Like that. And it looks like this one's got a connector going to the LED display. So let's unplug that as well. Try to. Right, let's put that on one side. Right, let's just zoom down a bit and see if we can see anything obvious. Well, they have an internal fuse. This is where the power comes in. Goes through a bridge rectifier, and then it looks like we've got a couple of mains caps here. That's the main switch and IC. I think on one of the other ones I looked at, there was a diode underneath the heatsink here. Down there that had failed. So let's get this board out, and it's held in by 4 screws. So let's get those out. And hopefully this board should just come out now. I'm stuck with a bit of this glue stuff here. Let's get that screw out of the way. Right, let's grab the test meter. So I think the first thing I'll do, I'll just check we've got continuity from the plug going to the circuit board. Let's go into continuity here. And if we go on to the neutral, oh, if I can get the probe on there. Right, so we've got continuity from there to there. Let's just see if it goes to the bridge rectifier. And it does. Right, let's just try the live. And we don't have anything to there. Let's just try here. We still don't have anything. And we don't have anything to there either. Let's pop this fuse out. Let's just check that. Right, so it looks like the fuse has gone open circuit. And it is a 3 amp. So, unlikely that's just gone by itself. There'll probably be something that's caused that to go. So let's just check the internal fuse, which is just here. And that is intact. So let's just see if we get continuity from one of those fuse holders to this point here. Yes, we do. Okay, so we know the circuit's okay from the plug, and the wire's okay up to this point. Let's just check if we've got a short on here. And we don't. Let's just check across the bridge rectifier. Seems a little bit low, that's 67 ohms. and we'll get that both ways. So let's just check the diodes in the bridge rectifier. So Want a diode check. So the two diodes going to this side are okay. Let's just swap the leads round. So the bridge rectifier is okay, but we seem to have some problem further on from there. So let's just check across the mains cap here. Just want the resistance. I've got meg ohms there. Let's try this one. I've got meg ohms there as well. So why have we got a 67 ohms reading across there? So that one goes to the switching IC, and the other one looks like it comes to this side of the transformer here. It'll then go through the transformer to the switching IC. So I wonder if the switching IC has failed, because that should be a MOSFET that's built into the switching IC there. So if that's failed, then we'll probably get the symptoms what we've got. So I might take that out. Let's just have a look, see if I can see anything else. And how does that come out? Because it looks like we've got to undo those two screws there to remove the heatsink, because you can't access the screw that way. And it looks like we've got some of that glue stuff on here as well, so that might be a bit fun trying to get those out. Looks like we've got the same here as well. So I'm going to see if I can pick away at this glue, see if I can get these two screws out, and then we'll take the heatsink off. Right, so I'll just go and do that. So I used the hot air rework station to soften the glue, and I've removed the two screws that were here and here. So next I'm going to add some fresh solder to this IC here, and then we'll use the little solder sucker to desolder it. Let's try adding some more fresh solder to this one. Right, let's see if this wants to come out. I still think it's held by some of this glue here. Glue and conformal coating, it seems. Right, there we go. And we have lost one of the legs on this chip, but I'm fairly sure it is blown in any case. Let's just see what reading we get. So it would be between here and here. I'll just zoom out a bit so we can get the meter in shot. And there we go, 75 ohms. Both ways. So this is the MOSFET on this switching IC is between those two pins there. So if I just go into diode check, I'll just zoom down so you can see. I'll just bring the data sheet up on this chip once I find out what it is as well, so you can have a look. So there you go. So the switching IC's failed. Let's see if I can see where it is. More glue on the back. I'll just grab a screwdriver here. Looks like it'll be a top of some description. And actually it looks seized to the metal plate here. I just want to come off. There we go. I'll just zoom it down a bit on that because it looks like it might have a bit of a black mark there on the side of it. And it is a top 264, I think that is. I'll just try and get a little bit of IP on that. Let's just see if I can see the number a bit better. Maybe actually made it worse. Well, I can see top 2.6. I'll just get that on a little spyglass just to have a look. And I think it's a top 261. I'll just try and clean this goo off a bit. Yes, it's a top 261. I'll just see if I can get the camera to focus in on that. There we go, top 261E. And if we look at the side of it, we have a big blast mark there. So it's going to need one of those. I might actually have one of those, because I think I bought one previously for another charger, so I'll have to have a look. Right, I've managed to find a replacement IC. There we go, top 261EN. So I'm going to put a bit heat sink compound on the back of it, and we'll put it on the heat sink, and then we'll install it. I'll just clean this old stuff off here first. That came out a bit quicker than expected. Right, we'll try that again with just a smear of it on. Right, see if we can get this bit in. Actually, I'm going to check those diodes and that first, just to make sure none of those are shorted out. So I'll just go on to diode check. Yep, that one's okay. That one's okay. That one's okay, and this one is just here. And that one's okay. Right, let's put this switching IC back in. I think I might have to take some of this glue out of the way. I wonder if this stuff will go conductive, like what's happened in some previous repairs. I've had it where this glue's gone conductive after a while. Right, so why aren't you going in? I'm just going to check those holes are clear. Right, let's try that again. Right, all the legs are there. Let's solder that back up. Actually, I might screw it in place first, just in case I screw it down. Just in case I solder it and then screw it down and bend the legs or something. Right, let's get that soldered back up. Just clean this up with a little bit of IPA. Right, I'm happy with that. Right, so I need a 3 amp fuse now. So I shall just go and find one of those. And back with a couple of 3 amp fuses. Right. Let's pop one of these in. Just better check it's actually okay first. Yep. Let's pop that in. I'm just going to put this just in here for the moment, just so we're not shorting anything out. Right, I'll get the dim bulb tester. Let's put that broken IC up there. Right, let's plug this in. And let's see what it does when I switch it on. So there might be a bang, there might not. Well, that was a good sign. Right, I'm just going to unplug that a sec. Well, it didn't go bang, I just want to see if we've got any voltage in that capacitor there. Or maybe that one. Let's just see if we've got any voltage in that cap. And yes, we do. So I think this is probably working. So let's just pop it back together and then we'll put a battery on and we'll see if it starts charging. Let's put those little screws in first, I think. And I also checked the two little capacitors here, but I forgot to press record at the time, so just in case anybody was wondering, and they measure okay. Because I was wondering what has caused the failure, but those chips can just go. Let's see if we can get this plugged back in. There's not much cable. Right, so let's just try a battery. Yeah. Well, that doesn't look good. Let's try that again. Just going to try a different battery here. So it seems like it might have more problems. Typical, isn't it? So maybe more than one fault on this. Right, I'll pull it apart again then. Right, I've got it apart again and I've got it plugged into the dim bulb tester. So what I'm going to do is just measure the output on the capacitors here, just to see what voltage we get. So I'm just going to volts DC. Alright, so it's on now, and this is the safe side, and the live side's over that way. So we're okay to touch around here. We've only got around 7 volts there. So the power supply is running, but I'm sure we're supposed to have a higher voltage here than 7. I'm just going to switch this back off a moment. So I'm sure those caps are rated 50 volt and 35 volt on the opposite side. So either something's telling the power supply to regulate down, which should be somewhere around about here, or there's still a problem on the live side here. Let's just zoom down a bit and see if we can see anything. I might have to get the microscope in on this, just so I can have a look over some of those resistors and that and stuff. I'll go and set the microscope up. So this is where the regulation comes into it, and there's the two opto-isolators that regulate the current and the voltage. I've got a 0 ohm resistor there, a 1K and a 10K. Let's try and get the meter in shot there. I'll just go into resistance and let's see. Conformal coating again. So that one's okay. That should be a 1K. Yeah. Yeah, that one's okay. We've got a 47 ohm. Yeah, that's okay. I've got a 100K here, I think it is. That's measuring 83 ohms, but I guess that's something else in the circuit. And I can't quite see what that one is. Let's just zoom down a bit more. Now, is that a mark on there? So that looks like 8R2, so 8.2 ohms. And we've got 26K. So that definitely looks blown. I'll see if I've got an 8.2 ohm resistor. Right, back momentarily. Right, I've just realised that the microscope wasn't recording there. But I've just replaced the resistor with a new one. I'll just give that a clean up. And let's just measure that that's working. Yep, just try it there. Yep. Right, so that one's working. So let's try this again now then. I'll just get the microscope out of the way again. Right, I've got it plugged in. Let's see what voltage we get on those caps now then. Just switch it on. We're still only about 7.5 volts. So I wonder if it only ups the voltage when we've got a battery connected. Let's just try that. I'll switch it off a moment. Plug a battery in. I'll switch it on now. Still 7 volts. Definitely looks like there could be something else as well then. So I had a little bit of a break from this, did a few little bits and bobs of jobs, and I've just came back to have a look at it again. And I was thinking, so the problem, or the main problem, seems to be on the input side. That's where the failure was. So I was wondering, has something gone wrong with the feedback side of things? And that's why it's not charging, because it thinks there's some kind of, you know, like over current or over voltage or something. So this resistor here was blown. Well, if we trace that, it comes up to here and goes to this opto isolator. And if we go back the other way, it goes through a link and it goes to the IC that had failed. That's just a link on the other side of the circuit board there. So what I thought I'd do, I'd just measure the resistance or see if there was a diode across here. Because one side should be an LED and one side should be like a photodiode or a photo transistor. So I'll just zoom out a bit and we'll get the meter in shot. And I'll just go on to diode check. So let's measure what we get on this one. And we don't get anything. Let's just check on the other side. So let's just check this one. And we get a diode there. And let's just check this side. And let's just check the other way around. So we're getting the same reading both ways across these two pins. So I'm just wondering whether this optocoupler has been damaged. So I think what I'll do, we'll remove it and then we'll test it out of circuit just in case there's a resistor or something that's across it causing the reading. So I'll just zoom back down a bit. And we'll just put some fresh solder on that. Right, I think that should be that out. I'll put a bit of flux on there and clean those little bits of solder things off later. There we go. That's just the conformal coating, I think. Right, I'll just zoom back out a fraction and we'll try testing those two pins now. Have we got anything on those two? Oh, that's right, we'll flip it round a sec. Just checking my meter there. And we'll just try these two. Ah, there we go. I'll just swap those around, I'll try to. It's a bit fiddly this, trying. It's always the same when you're trying to record something on camera, you know. It must be those two. Yeah, short that way. I'll swap my leads around and try that again. Short that way, right. So that's definitely not right, so I'll have to see if I can get one of those and then we'll fit it and see if that cures the problem. So that's the part there. So it looks like an L1343 and it's also got 817C written on it. Right, let's see if we can pop this in and we'll get it around the right way. Just going to check those holes are clear. There's one of them not clear, that's what the problem is. It's probably got some conformal coating or something on it. Right, let's try that again. Right, there we go. I'm happy with that. So both of these are facing the same way, and this is the LED side, it seems. Right, let's solder that in then. Hopefully without it falling out. Right, I'm just going to sort that bridge out. Just going to put a bit of flux on there. It's this conformal coating that's on it. I shall give that a bit of a clean up with some IPA and a toothbrush. Right, let's give that a go then. Let's plug it in and switch it on. And let's measure what voltage we get across here now. Well, we've got a higher voltage now, we've got 10.44, where before we only had 7. Right, let's unplug it and we'll put it back in the case. I'll not put all the screws in, but we'll try a couple of batteries in it just to make sure it's actually doing something, or doing what it's supposed to do rather. Let's see if I can get this cover plugged in again, which is a bit awkward. Right, let's switch it on. And let's try a battery, and fingers crossed. Yes! Oh. Hold on. It's because I've got the dim bulb tester still plugged in. I'll just plug this direct into the mains. Now this battery should nearly be full in anyway. And that's indicating that it's nearly full, so... Right, let's just try a different battery. Right, that seems to be charging. We don't seem to have the flashing error codes now, so that's good. So what I might do is just leave that on charge for a bit and we'll come back to that. And when it's fully charged, pop something under here just to keep it angled up slightly. Right, we'll come back when that's fully charged. So while I was waiting for the battery to charge, I thought I'd have a quick walk around the field, and these two have just been born. So I thought I'd bring them back up to the barn just to keep them out of the wind and that, because it's quite cold and windy tonight. So I just thought I'd share that with you. Right, just came in from being on lamb duty, and this one's fully charged. So let's unplug this battery. And I've got an M18 one there, that's got 2 bars in it, so I'll put this one on charge. I've still got to put the screws back in this yet, like, but... Right, we'll leave this one to charge, and then we'll come back to that when it's fully charged. Right, so this is fully charged now. We'll just take the battery out, we'll just double check. Excellent. So I think we'll call this one a fixin'. I just need to pop the screws back in. So, right, if you enjoyed this video, please give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.